Number 4 says to solve each inequality below and illustrate the solution on a number line. Because when you solve an inequality, remember you're saying all the numbers that are is like a set of numbers. Where are these numbers on the number line? It's not like saying x is equal to x. When you say x is equal to, you have to say there is a value that is equal to. So if you have x is equal to, whenever you see x is equal to, for example, you have a situation whereby you have x is equal to 7. Apart from saying x, in that case, you'll see there is a number. There is a number, which is 7. Okay. But when you have the inequation, all the numbers are that are because it's a set of numbers. Okay, if you put x is more than 7, there's not one number alone that is more than 7. There's a whole set of them, all the numbers that are. So inequations can be represented on a number line, but not equation. If you have to put on a number line, you just have to put a circle with no arrow, a filled circle, a dark circle on 7 with no arrow, because that's it, 7. Okay. But with an inequality, set of numbers on the right side of 7. So here we have a situation, and as you can see now, these examples, the x are positive, positive 5, positive 7, positive 5. But here I deliberately put a negative 2. So whenever you are solving an equation, in fact, especially an inequation, try to make your x as positive as soon as possible. Because with an equation, if you have to divide by a negative number, or you have to multiply by a negative number, you have to switch the direction of the inequation. You have to switch the direction of the inequality sign. So to avoid this switching of direction of the inequality sign, try to make your x as positive as possible. Let's focus on the x. We have a negative 2x. Let us add 2x on the left, add 2x on the right, so that we can end up with a positive x. In fact, a positive 2x on the right side. So now x is positive on the right side. So now we can cancel out. We can cancel out 11 by subtracting 11 from the right side. If we subtract 11 from the right side, we have to subtract 11 from the left side. Eleven cancels out from the right side. We are left with a positive 2x. 5 take away 11. We're trying to take away 11 from 5. You will still have 6 more to take away. Okay, commonly known as negative 6. Okay, but it means you still have 6 more to take away, because you can call that sign take away also. So now we are going to divide by a positive 2. So you can appreciate why we made that negative 2 positive in the first place, because we want to divide by a positive number. Divide by a positive 2 on the right, divide by a positive 2 on the left. The 2 cancels out. And 6 divided by positive 2, or negative 6 divided by positive 2 will give us a negative 3. And as you can see, our inequality sign keeps on pointing towards the right. Negative 3. Now what this is all the numbers that are less than negative 3. Always start reading from the x. X is less than negative 3. All the numbers that are on the left side of negative 3, if you want to put it that way. So where are these numbers? Because this is less than, x is less than negative 3. So remember what I said, when you see that, don't see the more than sign. You start reading from the x, and you have to say less than because the x is on the point. X is less than -3. So where are these numbers? On the left side of -3. -3 is not included. So start on -3, and here it is. These numbers are -4, -5, -6, right up to -infinity.